in the previous topic, we understand the definition of the momentum, and we understand that the momentum is the product of the moving mass times the velocity. The greater the velocity, the greater the momentum. Now, since the velocity is vector, then momentum should be a vector also. Then, another content which is very important is the impulse. And we understand that impulse, which is big letter G, is equal to the force times the time. Means the force once two object collides, the amount of force experienced by one by the force to by the object to another object is the force. Okay. Then the time of collision is we assign that at delta t. So if we multiply that amount of force by the time of collision, that will be the impulse. Then after that, we study the impulse momentum theorem, and we understand that the impulse, which is the during collision activity, is equal to the change in momentum, and the change will be the final minus initial momentum. The final is the after collision, while the initial is before the collision. Now today, let us study and derive the formula for the law of conservation of linear momentum. And we will apply this principle through solving problems in everyday life. Okay, consider an object. Let us say I have a mass of an object of, let's say, 10 kilograms and moving at 15 meters per second to the right. And I have another object which is greater in mass compared to the previous. This is 20 kilograms. And this is moving 12 meters per second. And they're moving in opposite directions. So, therefore, the two objects must collide. Now, the question is, after collision, what happens? That will be the problem. So therefore, again, we have this object, so we will, okay, so therefore, this will be the questions. If we have this uh, 10 kilogram mass and we have the 15 meter per second velocity, and in the other object we have the 20 kilograms and the velocity is 12 meter per second, after collision, what will be the velocity of its particle? Okay, so okay, this will be the before collision, and we have the during collision. This is where the impulse was formulated, because the impulse is the product of this force, which is the force that mass 20 kilogram mass exerts to 10 kilograms, which is the same as the force experienced by the 20 kilograms, which will be the force applied to the 10 kilogram. And the time of collision is assigned to be delta t. So if we multiply this, any of these force, because they are equal but in opposite direction, this is forming action-reaction. This is going to the right force, and this is going to the left. So the force should be the same. Now, this is assuming that there is no other external force interfere to this event. So meaning this should be placed in a vacuum wherein there is no other particle except the two objects collide. So this is the final collision. So, or after collision. So therefore, you might ask, how much is the velocity after? Is it greater or less than? Or is the same? So that will be the questions that we will provide the answer. And we will be using the concept of the law of conservation of linear momentum. So during collision, take note that we have again the force. If suppose this is mass A to make it general, and this is mass B, any mass will do. So if the two objects collides, this is during collision, there must be a force on A, and this force was exerted by mass B. So this is the force that B exerts on A. While in the object B, there's also a force, and this is the force that A exerts on B. Why? Because the two objects collide. So therefore, the two objects, these are the result of the interaction. we have the force that A exerts on B. Now remember that these two forces are the same. And the time in contact, again, we call this as the time of collision. So therefore, in our previous video, take note that we derived that the net external force is the change in momentum per time interval. So the derivative of the momentum with respect to time is actually the net external force. Remember, this is the relationship between the force and the change in momentum with time. Okay? So again, this force will be the next external force, any of these two forces. And this delta T should be the change in time. So therefore, we can always find this one if you are asked how much is the change. Or if the momentum initial and final was identified with respect to time, then we can always solve for the force. Okay. Now again, if we know how much is the force and we know how the time of collision, then we can always solve the J, because J is the impulse, the product of the force times the time of collision. Now take note that if we sum up these two forces, the force that B exerts on A and the force that A exerts on B, the sum should be 0. Why? Because they are, again, uh, these are forming interactions, action and reaction. So therefore, they must have the same. But take note, but in opposite directions. Therefore, if you add the two, the sum should be 0. Now take note that, okay, this is going to the right, so 1 is positive, and this is going to the left, so therefore this must be negative. So if you sum up this one, the 2 must be 0. Now take note that the force on force that B exerts on A can be replaced in terms of momentum. Okay? So therefore, the force that B exerts on A should be what? The change in momentum at mass A with respect to time. While this one, the force that A exerts on B, should be the change in momentum of the object B with respect to time. So let's substitute the values. Okay? Again, the force that B exerts on A is the change of the momentum of A with respect to T. And this force, which will be this one, is equivalent to what? The change in momentum of this object B with respect to time. And the sum should be 0. Okay? So, therefore, take note of this, that uh, we can take out the derivative because this is the derivative of P with respect to T, PE. And this is the derivative of PB with respect to, or rho PB with respect to dt. So therefore, we can take the common. So what will happen is we have the dt of the momentum of A plus the momentum of B. So this is forming the sum, which means that if we sum up the momentum of A and B, the change of that with respect to T should be equal to 0. Okay? So take note, this is sum. Okay? So therefore, we can see it the total momentum. Because if you add momentum A plus momentum B, the result will be the total momentum. So call it as the dp total, which is equal to the momentum A plus momentum B with respect to T. The sum should be 0, or it is equal to, means the change in the total momentum with respect time is always equal to 0. Okay, so therefore, okay, if you take diagonal product, this will result as the derivative of the total momentum must be equal to 0, which means that if you sum up force B exerts on A with the force that A exerts on B, it should be equal to the change in total change in momentum, and the result should be 0. So if we integrate this one, take note, if we integrate this, because this is a differential equation, we'll come up that we can say that the total momentum must be a constant, or the change in momentum, okay, the change in momentum should be equal to 0. So what does this mean? Now, what is total momentum? Total momentum means this is uh, the algebraic sum of the what? The algebraic sum of the initial momentum and the final momentum, or the change in momentum. Okay? So, therefore, if the vector sum of the external, because take note that we assume that this is occur in a vacuum, so therefore there is no other external force except these two forces only. So if the vector sum of the external force on the system is zero, this is one, zero because there is no other external force. So then the total momentum of the system should be a constant, and this is the meaning of this. Okay, or the total momentum should be equal to zero. Okay, so take note again that the total means what? The total means the final minus initial. So in other words, if we sum up the total final momentum and the total initial momentum, the sum should be zero. Okay? So what is initial and what is final? If we transpose this to the other side, then we can say that the initial momentum total should be the total final also. So you consider the two colliding objects. We have the mass A and we have the mass B whose velocity is v sub a1. V sub a1 means the velocity of this mass A at initial condition or initial point. Where VB1 is the initial velocity of the mass B. This is the initial velocity of the mass B. Okay? Then take note that these two objects will collide. So we call this as, this is before collision. Before the two object collides, we call this as the initial condition. So this will be the initial. So working with this formula, if you are asked how much is the total initial momentum, the answer should be the momentum of A initial plus the momentum of B initial. If add this algebraically, then the result will be the initial momentum. This is the meaning of P initial. Okay, then uh, take note that they will collide. And after that, the two object will, and after collision, their velocity will change to each other. So in the initial condition, they are moving towards each other, but in the final condition or collisions, the object will opposite in opposite direction. Okay, so what is the total final? Because we know already that total initial, it should be the initial of the momentum A initial plus the momentum of B initial. That will be the initial momentum. Now this final momentum should be the sum, algebraic sum of the momentum of A final plus the momentum of B final. Now take note, momentum means the product of the mass times the velocity. So we have the mass and we have the velocity. So that will be the momentum, the product of the mass times the velocity. So therefore, we can say that the total initial momentum should be what? The initial momentum, okay? The initial momentum of A, mass A, which is representing PAI. So this is the initial momentum of object A. Should be added by what? Should be added by the initial momentum of the object B. So it should be added by plus momentum of B, PB initial. So there are only two objects collide. So therefore we have the momentum A initial plus momentum B initial. This should be equated by what? Is equated by the total final momentum. What is total final momentum? It is this object. Now take note that we have another momentum here because the velocity is changed. So therefore, multiply the mass or the velocity. This is the momentum of A final plus the momentum of B final. Okay? So next is apply the definition of momentum, because momentum is mass times velocity. So this should be what? This should be the mass A times velocity A initial. Okay, this is the momentum A initial. While the momentum B final, initial also, this one should be the mass times the velocity, representing BB1. Now this should be equal to what? The momentum of A final. Momentum of A final is this one. So therefore, mass A times the velocity A final, or VA2. This will be the momentum of A final. Then added by what? The momentum B final. So it should be mass B times the velocity B final. That's it. We call this as uh, the law of conservation of linear momentum. Now remember that velocity, momentum is a vector's quantity, so we are always concerned with the what? Direction. So take note, one of this, look at this one. If you use this formula, because this is the law of conservation of linear momentum, because therefore once the object, any object collides, then we can always apply the law of conservation of linear momentum. It is moving in straight line. Okay, so therefore the law says that the initial momentum total should be the total final momentum. So it is always true to all particles that collides each other. So therefore, take note that again, vector B is vector, so we have to provide the direction. So in other words, all you need to do is to overlay the Cartesian of the activities for the before collision and the after collision. So you have to be consistent. Since the motion is, this is only one directional, so this is along x, then it follows that what? Uh, we have only the positive x and negative x. So therefore, in this case, if you assign this as positive x axis, so the velocity A initial should be a positive value. So therefore, this will be positive. Okay. Now, while the momentum of B initial, the velocity is towards left. So therefore, this must be negative. So this should be substituted algebraically. This should be negative. So if it's negative, multiply positive, this term becomes a negative. Now, in the final, okay, because if you are very sure that this is moving towards left, then all you need to do is to substitute a negative value. Okay? Then this one is a positive value. So, again, this is the law of conservation of linear momentum. So, therefore, if mass given, mass A is given, and you have this velocity, and you have this mass B is given also, and you have this velocity. Now, take note, this is also the mass in the final. Now, suppose one of this is given, it's either these two. So, therefore, you can always, suppose this is given, so therefore, you can solve for the velocity final of mass B. Okay? So, again, this is the law of conservation of linear momentum. The initial momentum should be equal to the final momentum. Or, the total momentum, which is the initial and final, the sum should be 0. Because the change in momentum is always a constant. And the force during collision, which is the force that B exerts on A and A exerts on B, the sum should be 0. Considering, if we assume that there is no other external force, which means that the two objects ignore the effect of gravity. So imagine that the object is placed in a vacuum. Now, in the actual activity, for example, two cars collide each other. Now, we have to ignore some factors that affect the collision. So, for example, the friction in the road. So, we will ignore, because if it is if the two object collides, then the friction now becomes negligible, because we are concerned with the velocity and its mass. Okay, so it is nearly a vacuum. So therefore, we can always say that the law of conservation of, because the law of conservation of linear momentum assumes that there is no other external force. Okay, so let's apply on how this formula, how to apply this one to everyday life. So one example is two cars that collide each other. Okay. Now, suppose I have the object. Let us say this is point 3. And this is moving to the right with 2 meters per second, assuming that there is no other uh, outside force that affect the motion. Imagine this is a vacuum. Or suppose that object is lying in horizontal where the surfaces are very very smooth. Okay, then it is moving with the direction along x, let us say 2 meters per second, whose mass is 0.3. And the other object is 0.5 kilograms. This time, this is moving towards left with the same amount of velocity. Now, take note that they are in opposite direction towards each other. So, the tendency is they will collide. Okay? So, this is before collision. Then, after collision, what will happen is it will bounce back to each other. So, therefore, the question now, if after collision the 0.3 kilogram is 2 meter per second, the same, okay, the same velocity, what will be the final velocity of 0.5? Okay, so on this problem, this is always uh, this can be experienced in everyday life. Why? Because any object, any particle that collides each other is actually can be solved using the law of conservation of linear momentum. So, how much is the velocity? That will be the question. Okay. So, to answer this is, okay, we have to analyze before, okay, and after. So, no need to analyze the during collision. Why? Because take note that in our previous law, the law of conservation of linear momentum, it is talking about the initial and the final. The initial condition, the initial collision, and we have the final collision, or the before collision and after. Now take note that uh, the total momentum should be zero. So therefore, we need the initial and we need the final situation. So in this case, the initial is the object 0.3 kilogram is moving towards right with a velocity of 2 meter per second, while the 0.5 is moving to the left with velocity 2 meter per second also. So after collision, what will happen is, problem says that this object moves, if this is, okay, based on this problem, this object, point 3, will move in opposite direction with the same amount. Now, what will be the velocity final of the object whose mass is 0.5 kilogram? So, we have the before and we have the after collision. So, again, before is the initial and after will be the final. So, we will use this formula. Okay, the total, what is this one? This is the law of conservation of momentum principle. So, the total initial momentum should be equal to the final momentum, which means that if we add these two again, the sum should be 0. So, the sum should be 0 because this is according to the law. The initial momentum is always equal to the final momentum total. Okay? When we say total, the momentum of the two colliding particles. So, the initial should be what? Should be the momentum of this particle added algebraically with the momentum of the other particle. So this will be our total initial. And the final should be what? The final should be the momentum of this particle added algebraically with the momentum of this particle. Then solve for the unknown. And we are very sure that the unknown is this one, B. So we can solve this one because this is the problem. Okay? This is the problem. Then, okay, so the momentum initial of the object 0.3 kilogram is that mass 0.3 kilogram multiplied by its velocity. So this is the momentum of this object initial. This should be added. Okay, this is plus. Okay, why plus? Because we assume that to the right should be positive. Okay, to the right should be positive. So therefore, this should be positive 2 meter per seconds. Then added by, because you have to add algebraically, by the mass, because the mass is always positive, so this is 0.5, but the velocity now is negative 2 meters per seconds. Okay? So then, this should be equated to what? Equated to the total final momentum. And the total final momentum should be the product of this 0.3 kilogram with the final velocity, which is the same as 2 meter per seconds. So this will be our momentum of this 0.3 kilogram final, and added by the momentum of the object 0.5 final. It should be this object times this mass 0.5 times the velocity. So the unknown is v. Okay? So look at the equation. The equation contains only one variable, and that is v. So therefore, use the algebra. Okay, you have to transform this one, transpose this to the left side, then divide both sides by 0.5, then solve for v. So that will be the result. Okay. So take note, this will be negative. So therefore, so this is negative, negative, this will becomes plus. And this is negative, positive, this will be negative. Use your calculator, sum up this, divide by 0.5, and the answer is 0.4 meter per seconds. Okay? So what is this velocity? This is the velocity of the 0.5 kilogram object in the final uh, collision or after collision. So this will be the final velocity of the object, because the initial is the initial is 2 meter per second. So after the collision, it will reduce. It must reduce, okay, in order to balance the final to the initial. So therefore, no way that the final will be greater than this, because if this is greater compared to the initial, now you cannot equate the two. Okay. So therefore, look at this one to verify. If you add this one, if you add the momentum of A plus the momentum of B, it should be 0.3 times 2, 0.5 times 2. It is always the same as what? The momentum, the total momentum defined. So which means that the sum of this, okay, this two momentum should be equal to 0.3 times 2 plus 0.5 times the velocity is 0.4. So if you add the two, the sum of this momentum should be the same that momentum. Okay? Now, this problem is a kind of elastic. Why? Why? Elastic collision. Because, by the way, in the next video, we will study about collisions. There are two kinds of collision. We have the elastic and we have the inelastic. This problem is a kind of elastic. Why? Because the object will separate each other. Okay? Then one will bounce back. So therefore, this is a kind of elastic. So therefore, again, because the two object collides, we can always the principle of the law of conservation of momentum, whether elastic or non-elastic. But for the elastic, the two particles, okay, the initial activity, aside from constant, the total momentum is constant, or it is the sum should be zero, then the energy also is conserved, which means that the energy initial, the total energy initial, is also equal to the total energy final. Remember, energy means what? We have only one kind of energy. We have the kinetic energy, because we have the mass and we have the velocity. So therefore, we can solve the kinetic energy initial object A and the kinetic energy of the object B, or zero point 0.5. So if you sum up this one algebraically, because by the way, the kinetic energy is always positive, because when you square the velocity, This one is negative. In U square, 1 half mv square, the energy is positive. So if you add the energy initial of this object added by this one, this should be the same. If this is elastic, okay, if this is elastic, the energy in the final of point 3 added by the energy of point 5 kinetic energy, the sum of this should be equal to the sum of the initial. We call it as conservation of energy. So the conservation of energy can be applied for elastic collision. So for your practice, okay, try to compute the energy initial, the total energy initial plus the total energy final. This should be zero. This is also to verify. So if the two energy is the same, then we can say that this is elastic. If not, then therefore this is not an elastic collision. Okay, so this video is limits only for the derivation of the law of conservation of linear momentum, and we applied that with this problem. And we will continue discussing about collision, about the conservation of linear momentum through different kinds of collision. And that will be in the next video. Okay, so for now, for your practice, can you solve this problem? Okay, uh, if try this. If you cannot solve this one, then review the video, then try another source. We cannot accommodate to solve more problems because we are limited with time. So all you need to do is to solve this one. This problem are taken from the book of Young and Friedman. So I usually mostly of my discussion are taken from that book. So these are found in the problem, and I use this for your practice, okay, in order to verify your knowledge in the conservation of linear momentum and its application. So in the next video, we will study the collision, the elastic and inelastic collisions. What will be your calculation now if it is elastic and inelastic? Okay, so that's all. Thank you.